So Azure Storage account is used for storing the data like blobs, table, queues, files, and hard disk of virtual machines. So these all objects can be stored in Azure Storage account. Okay? And these objects are accessible over the internet using HTTP protocol, and the data is stored in Azure Storage account, so it is highly durable and highly available. Durable means even even if there is some disaster in the data center, okay, so if we have planned proper data storage, then it will be available to us. So we will see how to plan that data storage so that even in the case of disaster we can get our data. So I will show you in the next slides. This data is secure and encrypted. Okay, so let us go to Azure portal and see how we can create a storage account. So this is my Azure portal. I have already logged in, and you can navigate from here, all services, create a resource. You can directly click on this plus sign. Now we can search here the storage account. So this is the resource which we are going to create, a storage account. So click on create button. So I'm using this free trial subscription. So if there are multiple subscriptions, then you can select. Now I need to create resource group. Resource group is used for grouping the resources, so which I have covered in previous session. So it is I'm going to create new resource group. Okay, so click on OK. Now I'm going to give a storage account name. So it should be unique, demo storage. Okay. So this name should be unique. And now location is already populated. We can select our location. The performance tiers. So there are two modes of performance tiers, standard and premium. So if you select standard, then data will be stored on HDD. Okay, and if you select premium, then data will be stored on SDD, solid state drive. So obviously this is costly if you select premium, but it will give better performance as compared to standard. Now we have to select the account type. So there are multiple types of account here. General purpose storage account V2, general purpose V1, and blob storage. So this general purpose storage V2, it is the latest one from Microsoft Azure, and it is optimized for best performance. Microsoft also recommends to use this one. So it is used for storing blob, queue, table, file, and hard disk of virtual machines. So it is recommended for most of the cases. The second one, general purpose V1, it is legacy, and it is not optimized for the new latest features. Okay, so it is just for general purpose. If you want to have a storage with the normal features, then you can select general purpose V1. The third one, blob storage. It is optimized for your blob storage. So if you want to store only blob, then you can select this one. So I'm selecting storage B2. Replication. So replication defines how our data will be stored. So whether there will be multiple copies of your data, whether it will be stored only in one data center or it will be replicated in multiple data centers. So these all things are decided by replication. So there are multiple types of replication. Okay. So I'm selecting this one, locally redundant. Okay. So I will explain what are the features and benefits of each and every replication type. Okay. Then click on networking, click on data protection, advanced, and from here we can decide where blob it will be available for anyone without login. Okay. So from here we can decide, and there are access tiers, cool and hot. Okay. So cool means we have large amounts of data to store, but that data is are not very frequently accessed. Okay. It's not very frequently accessed, and but size of the data is large. In that case, cool cool tier will be uh, visual for us. Hot tier is used when we have very frequent data access. So data amount is less, but we have to access data frequently. Okay. So in that case, data access is cheap, but the storage is expensive. So when you have less amount of data and it is frequently accessed, then you should select this hot access tier. When you have a large amount of data and that is not frequently accessed, in that case you should select cool access tier. Okay. So if we do not select anything, by default the hot access tier will be selected. Okay. Now click on review plus create. Click on create button. So it will take some time to create this resource. So storage account is created now. Okay. Now click on this link, access keys. So these keys and connection string, these are used if we want to access storage account from .NET code or from some any other device. So if you are going to access from the portal, so that there is no need for key and connection string. And but if you need to upload some blob files and do work with the storage account from C# code, then connection string is used. Okay. So I will show later how to use this connection string. Then we have blob service. So we can create a container first. So container is just a it's a logical container for our blobs. So the top level is storage account. You can see this is the storage account. Okay. Inside the storage account we have container, and inside the container we can create blobs. So I will explain after this. I will explain what is blob and what are the types of blob. So we have to create container first before uploading any blob, and this is the file service. So file share is used for providing a centralized file share for your application. So in your application, if you are creating some files from your project, like if you're creating some XML files, some policy documents, in that case you need a centralized space where you can create your files. So this file share provides that centralized space. And we have table service. So table service provides NoSQL database. Okay, so using this table service we can create NoSQL database. I will explain it later. We have queues. So as you know, queues works on the concept of first in and first out. So queues can contain multiple messages, and basically it is used for decoupling two systems. I will explain this later. So these are the features of storage account. Now the types of objects which we are going to store in the uh, storage account. So the first one is blob. Full form is full form of blob is binary large object. So basically it is unstructured data like audio files, video files, PDF document, images. Okay, so the document which has binary data, so blob represents that file, and using this blob type we can add video files, audio files in our storage account. Okay, so blob storage is used for accessing images or documents over the internet using browser. We can also store files or video files, audio files for distribution purpose, like content delivery network. So content delivery network host like some files like jQuery files, bootstrap files. So similarly, for our distribution purpose, we can host our files using blob. We can use blob for streaming video and audio files. We can also use blobs for maintaining logs files. As we are aware, in our .NET projects, we have to write logs for tracking purpose. So we can use a blob for maintaining log in our application. We can also use it for storing backup files. And as I have previously told you, that it is also used for the hard disk of virtual machines. So hard disk of virtual machines are stored as blob. So if you have some audio file, video file, or some PDF images, then it should be stored as blob in storage account. So we have three types of blob. The first one is blob, second one is append blob, and third one is page blob. So blob is used for storing very large files. So suppose you have some file around 1 GB, like video file of 1 GB, then you can select blob to upload that file in our Azure storage account. So we have multiple blocks. So if there is 1 GB file, so we have blocks of 4 MB, 4 MB, 8 MB, 24 MB. So we can decide that block size from the portal, and if whenever we are creating blob, we can define the size, and when we are uploading the file, say file size, suppose file size is 12 MB. So in that case, if our block size is 4 MB, then it will be divided in 3 parts, and each part is uploaded simultaneously. So this is the benefit of using block type. So our big file is divided in multiple blocks of 4 MB, 8 MB or 16 MB, whatever we decide. So all the parts of big file are they are uploaded simultaneously. The second one is Append Blob. So basically Append Blob, it is used for it is also a type of blob, and it is used for the maintaining the log. So in Append Blob, every time data is appended in the end, like you have seen the logs files. So we are appending the new information in the log file in the end. So in case of Append Blob, data is always added in the end, and it can also have a block size of 4 MB or 8 MB or 16 MB. So it is just a type of blob, but the feature in this Append Blob is data is already appended in the end. So we can have up to 50,000 blocks. Then we have page blob. So page blob is used for a random read and write access. Like in hard disk, you can create a folder anywhere, you can create file anywhere, you can open any file, you can update any file, you can read any file. So if you want a random read and write access, then page blob is the best option. So hard disk of virtual machines are stored as page blob in Azure. So blob is used for storing big files like video, audio files, images. Append blob is used for maintaining the log in application, and page blob is used for random read and write access. So apart from blob, we have file. So file type, it is optimized for storing a file, and if your application is using some files here, then this is the best option to create a file share in cloud and to migrate your application along with the file share. We have queue storage. So in the queue, we can store multiple messages, and messages are retrieved in first out. So the message which is added first will be processed first. Okay, and it is used for decoupling two systems. So suppose your application is using some web service or some web API or some WCF service. So your application is the client of WCF service. Okay, so if WCF service is down, then the messages which are sent from your application will be lost. In that case, for removing this dependency between two systems, we can introduce a queue, and our application. Okay, so our application can add messages in the queue, and whenever the WCF service is available, it will pick the messages from the queue and process those messages. So we can introduce queue for removing the dependency between two systems. And then we have table storage. So table storage, you can think it as your normal SQL database, but the data is schemaless. So you can in single table you can create multiple records with different columns. This is the concept of NoSQL. So I will show you how to add the records in table using there is one tool called Azure Storage Explorer. So we will see that tool. So you can think a table equivalent to a database. Okay, so a table in Azure, it is equivalent to a database, and we have partitions for each and every independent table. So the whole database can be treated as a table, and for individual tables we have partitions. So I will show you how to add the records in the table. And I have already explained this general purpose v2, general purpose v1. Okay, so before moving to this redundancy, so I'm going to show you Azure Storage Explorer. So this is Microsoft Azure Storage Explorer, and we can download it. So this is the URL for downloading the Azure Storage Explorer. So we can install this on multiple operating systems. So it supports multiple platforms. So after downloading this, we can install it, and you can search here Azure Storage Explorer. So this is the tool, and we have to provide our account details by clicking on this icon. So I'm already logged in. Okay, so you can add another account. Now we will create some resources in portal, and those resources will be fetched here. So I have this storage account, demo store. So now I'm going to add some container in this. So container is used for storing the blobs. And we have these access levels. So private, no anonymous access means if some user is not logged in the portal, then he will not be able to access this. So we have a blob access, container access. So if I set this blob access, so user is not required to log in, and it can has the access of blob. In case of container access, so it will give access to all the blobs inside a container. So I'm selecting this one, blob. Click on create. Okay, so container is created. Now we can upload blob in this container using the portal as well as this storage explorer. So if you refresh here, so the container will be reflected here. So you can see storage accounts, demo storage, containers. So this is the container. So we can upload blobs from this tool as well as from the portal. So from the portal I'm uploading, select a file. So by default it is creating block blob because it is individual file. and from here we can decide the block size. So by default it is 4 MB, and this is the access tier. So by default it is hot access tier. So we can select cool or archive. So in case of archive, if you have a large amount of data which is rarely accessed, you just need that for backup purpose. Like you have some database backup files which is not very frequently accessed, it is rarely accessed. So in that case we can select this archive. So in archive, the data storage is very cheap, but data access is expensive. So when you have the requirement to store large amount of data, but the access is not frequent, it is rarely accessed, in that case we can select this archive. So by default it is hot. Okay, and I'm clicking on this upload button. So now we have created a blob, this one, and it will be also reflected. We can download from here. It will be also reflected from tool. So click on refresh. Okay, I have to select container first, container, then demo container. So it is available here. Might be it will take some time. Okay, I'm going to uploading. Okay, there might be some connectivity error. So we can select from desktop, clicking on upload. So it is transferring the data in cloud. Now it is successful. So this is the document which we have uploaded from the tool. Okay, so whatever document we upload from here. Yeah, and the file which we have uploaded from the portal, it is also visible here. So there was some network connectivity. issue. Now it is visible here. So this file first.txt we have uploaded from portal, and this file dapper for .NET developers we have uploaded from this tool. So this file is also visible in portal. Okay, so using this way we can manage our files. Now I will create some queue. File shares, click on file share. Click on create. So we have created this file share. We can also click use. So click on this. Now queue is created. We can also create tables. Table. So we have created a table, hospital management. So it is equivalent to a database. So clicking on OK. So we have created, first of all, we have created containers. So this is the demo container we have created. Then we have uploaded blobs. So this blob I have uploaded from portal, and this one is uploaded from the tool. Okay. We have also created file share tables. So we will add record in this table from tool queues. So in this queue we can also add messages from portal as well as from tool. Okay. Now on tool. So we have containers, we have file shares. So this is the file share which we have created, and we have queues, demo queue. So we can add messages from here, and this message will be reflected in the portal. And this is the table. Now I will show you how to add records in the table and how partition works. So click on add. So we have a single table, hospital management, and it is equivalent to a database in our SQL Server database. So partition represents a particular table, like in hospital we have patients, doctors. So we can store data of patient and doctor using this partition. So partition key I'm giving here patient. Row key is the primary key of the row, like P01. Now we can add our property, whatever we want. Okay, so click on insert. So this record will be inserted in table. Now click on add again. Now we will insert data for doctor. So now we are creating another partition for doctor, and this is the primary key for the record D01, and we are not going to use these two columns. These two columns are used for patient, so we can delete. Click on add property. Now click on insert. So now we have two partitions. Okay, one partition for doctor and one partition for patient. So these can be treated as two tables in database. So now you can see for doctor, patient name and patient is not applicable, so it is null. And for patient, doctor name and doctor address is not applicable. Okay, so we have two partition in our database. So this is the concept of NoSQL. It is schema-less because for each and every record we can create our own columns. Okay. Now we are going to see the redundancy. So storage account redundancy, it defines how data is stored in a storage account. So the cheapest one is LRS. It's a locally redundant storage. In LRS, there are 3 copies of data. So whenever you are, suppose you are uploading some file, so 3 copies of that file will be created in the data center. Now the question is, what is data center? So data in a data center, we have multiple servers. Okay, and each data center has its own power, cooling and backup system. So when you are adding some file using LRS, so there will be 3 copies of that file in the single that data center. Okay, so it is the cheapest one, but it does not have durability. If there is some problem, if there is some fire, if there is some natural disaster and you have stored your data using the LRS, then your data will be lost. You will not be able to recover the data. So now we will see zone redundant storage, ZRS. So in case of ZRS, data is stored in multiple zones. Okay, so like if your primary region is India, in that case data will be stored in the zones which are available in that region. So if you are uploading a file using the storage account and you have selected the redundancy as ZRS, in that case there will be 3 copies, and these 3 copies will be stored individually in each zone. Okay, so this is the better as compared to LRS, because if there is some problem in one zone, your data is still safe and it can be recovered from the another zone. Now we will see another redundancy. This is the geo redundant. So in case of geo redundant, we are going to use primary as well as secondary region. Okay, so data is copied 3 times in primary region using LRS, and after that it is copied in secondary region in a asynchronous way. Okay, so if there is some problem in primary region and you have used you have used this GRS redundancy, then data will be recovered from the secondary region. Okay, And then we have geo zone redundant storage. So it has benefits of both geo redundant storage, GRS, as well as ZRS. So in case of this, in the primary region, data is stored using ZRS in three zones, and after that data is stored in secondary region using geo redundant storage. Okay, so this one includes benefits of both strategies. So this is the best one, but it is also most expensive. Okay, now we will see how to upload some blob using C# code. So we will see block blob and append blob. Okay, so for that we are going to create console applications. So click on this, create a new project. So I'm creating console application. So click on create. Okay, so we have to add one NuGet package, and this is the Windows Azure Storage. So click on tools, NuGet package manager, manage NuGet package for solution. Windows Azure Storage. So click on browse, Windows Azure Storage. This one, Windows Azure Storage. So select your project and click on install. Okay, so we have to reference these two namespaces. So the first line, it is representing our storage account. So we have to pass the connection string So I'm going to storage account. Okay, this is your storage account. Click on this button, show keys, and copy this connection string. So click here. So change this connection. So I'm pasting that connection string which I have copied from portal. You can see demo storage. This is the storage account name. So we have referenced our storage account, and for working with the blob, we have blob client. Okay. After that, we will get reference for the container. So the container name is, so this is the container. Container name is demo container. Okay, already here, demo container. And then we are going to reference this blob. So I'm creating a blob with the name ebook, and I'm uploading this file. So I've already given the path. Okay, I'm running this project. Now file is uploaded. Now we can check it on portal. So on portal, go to demo container, and you can see this ebook. It is just recently added. So from here we can download it. So it will download the file which we have uploaded. Now the next demo is Append Blob. So we have to use we have to add NuGet package, Windows Azure.storage, and the code is similar. We have cloud storage account, then we have blob client. Okay, and then we have container, and the difference is only this one. We have created Append Blob. Okay, so we have just given a reference here. If this does not exist, then we can create this by calling this method. And after that, I have provided two file names, okay, first and second. So in this project, I'm adding another, or I'm using this code. It will be quick. I'm just commenting these two lines. So we have code up to container. Okay. and we have created this append blob. So this does not exist, and it will, we have put a check here, so it will create this. Okay, so if you check on portal, so there is no append blob here, it will be created through code. Okay, and after that we are appending two documents. We are appending two documents. So because in case of append blob, we are appending the data in the end, in the blob. Now we can check the content of the files which we have just appended. So first.txt, it has this sample text, and second. Okay, so our final blob will have a content from both the files. So now refresh here. So you can see the append blob is created here. So this append blob will have the data from both the files. So you can see this. So this is the data from the first file, and this is the data from second file, and these are appended in the append blob.